Let's just go through these each one by one, just so we're all clear on how to get these things done. This says construct a group frequency distribution for the data set. You want 10 classes with a nice width. That's the weird part. What is nice? Um, we should label them with interval notation, yada, yada, yada. Each class should be multiples of the class width. I'll explain that. So for all of these problems, the first thing you want to do is find the range. We're going to take the highest value, which we're going to look through this and try and find the highest value. Looks like 483 is the highest. And the lowest kind of sticks out. That's just going to be 2. So I subtract it to get the range. My range is 481. Okay, as soon as you have the range, the next step, since we want 10 nice classes, I'm going to take 481 and divide it by 10. For all these questions, you're going to want 10 classes, so you'll always divide by 10. So I get 48.1. Now here's the weird part. It wants you to have nice sized classes. This is our class size right now. That's not very nice. 48.1 is not a very pretty class size. By nice, they mean multiples of like 10 or 25 or 50 or 100, something like that. Okay, so we're going to take this number, we're going to round it up to the next quote unquote nice number, which looks like it's going to be 50. So our class size is 50. All right, each class we make is going to have a size of 50. Now here's where this multiple of class width comes into play. Our first class has to start at a number low enough so it'll fit our lowest value in it. So 2 is our lowest value. So what's the next lowest number below 2? It's kind of a stupid question. That's a multiple of 50. Well, that's going to be 0. So the first class is going to start at 0. Okay, let's just say that the lowest value was 180. Okay, ignore the 2. Let's just say the lowest value of 180 was 180. What's the next lowest number below 180? That's a multiple of 50. Well, if that was the case, I would start at 150. It's a multiple of 50, and it's the next number below 180. That's a multiple of 50. Okay, if the lowest number was 265, you'd start at 250 and stuff like that. Okay, so we're going to start the first interval at 0, and we're going to use interval notation. So we're going to use these square brackets. That's a square bracket. Okay, it's right next to the P on your keyboard. So if they're a size of 50, that means the first one starts at 0, so the second one's going to start at 50. The third one's going to start at 100, and so on. So if this interval starts at 0 and the second one starts at 50, this interval is going to go up to 49. We're going to put a right bracket on that guy. And you separate them with a comma. If you don't use square brackets and a comma, it's going to mark it wrong. The second interval goes from 50 to 100, so this is going to go up to 99. 100, this one will be 150, so this will go to 149. So go write out all the intervals like that, and then you have the painstaking part of counting up how many data points fall into each interval. So this will be the left column. The frequency, it looks like just 1, so the frequency of the first guy will be 1. You go through all the intervals and count up how many numbers fall into that range. Okay, that's how you'll do all those types of problems. All right, this is question 44. This says the stem and leaf plot above shows the house sales price over the last week in Tacoma. What is the most expensive house sold? So these are the stems and these are the leaves. When you have a stem and leaf plot, these symbolize, usually they symbolize like the 10th digit, and this is the 1's digit. So if I had like a stem and leaf plot that looked like this, let's see if I had 0, 1, 2, and I had 4, 7, 1, 3, 9. That would be the numbers 0, 4 or 4, 0, 7 or 7, 1, 1 or 11, 2, 3 or 23, and 2, 9 or 29. This is the tens place, and this is the ones place. But here it says this is 100,000s, and this is 10,000s. So let's just look for a random point. If I took the point 1 and 8, that represents 180 thousand. Okay. But it wants the highest, the most expensive house sold. So that's going to be this one, 3, 4, which is 340,000. That's your answer, 340,000. Okay, that's how you read 7-leaf plots. Let's see here, 22. Okay, we have X bar here. It wants X bar, which is the same thing as the mean or average. Okay. To do that, I'm just going to add up all the data values and divide by the number of values there are. 19.9 plus 4.7 plus 30 plus 15.5 plus 21.9. There are 5 data values, so I'll divide by 5. It says the 2 decimal places. Well, our answer is going to be only 1 decimal place. This is going to be 18.4. If this said find the standard deviation, okay, don't use a calculator. Let's just say I asked for standard deviation. You're going to go to the internet and you're going to go to Google standard deviation calculator. Okay. You can use the first one, plug in the values here. Just make sure you hit sample and hit calculate. And it'll do it all for you. It'll give you the standard deviation right at the top. Okay. Don't use the formula to find it by hand. Does that make sense? Well, you can't answer me because you're not. Or you can use your calculator to do this. I'll show you this real quick on your calculator. So if you're given data like this, the first thing you want to do is go to stat. And we're going to hit edit. We're going to edit our list. So you have this screen here. I'm going to put the data in this screen, 19.9, 4.7, 30, 15.5, and 21.9. Once my data is in L1, I'm going to hit the stat button again. Stat. And want to calculate something. So I'm going to go over to calculate. And I want to calculate some statistics. So statistics on one variable or one variable statistics, that's option 1. And it wants to know where's the data coming from. Well, I put the data into L1. So I'm going to hit L1, leave frequency blank, and I'm going to hit calculate. You'll get a bunch of stuff to read out. But look, the first thing is X bar. That's the mean. That's 18.4. If you want the standard deviation, that's going to be this guy right here, S of X. Okay? That's your standard deviation. So this would be 9.289 or 9.29 if they ask for your standard deviation. Don't ever use the formula for standard deviation. Okay? This one here, it says based on the histogram above, what's the class width? How big are each one of these bars? How wide are each one of the bars? This is going from 1 to 5, 5 to 9. These things are going up by 4, 4, 4. So the class width is just going to be how wide the bars are, 4. Okay. What is the sample size? How many things are represented in this bar graph? Well, between the values of 1 and 5, I have 10 things. This is a height of 10. Between 5 and 9, I have a height of, or I have 7 things. Between 6 and 8. 4 here, 8 here, 5 here because it's between 4 and 6, and 9 here. So to get the total sample size, just take these numbers and add them up. It's going to be 17, 21, 29, 34, 43, I think. 43 things are represented in this bar graph. Okay. Let's see here. We have 41. All right. We have this big array of data. It's real ugly, confusing data. It says find P67. What is the value of the locator? Basically, what number box? This is box number 1, 2, 3, 4, ... There's 117 boxes. Which number box is the 67th percentile? So which box cuts off the bottom 67%? So what I'm going to do is say, all right, there's 117 boxes. I'm going to multiply that by 67%. I get a decimal. I get 78.39. So the 78.39th box will cut off the bottom 67%, but you can't have 0.39 of a box. So we're just going to take this number and round it up. So the 79th box is the 67th percentile. So this is going to be, the locator is 79. So then it just says use the locator, give the value for the 67th percentile. What number is in the 79th box? Well, that's kind of a pain in the butt to do, but we have 1, 2, 3, 4, 5, 6, 7, 8, 9 boxes across. So this is the 9th box. This is the 18th box, 27th, 36th, 45th, 54th, 63rd, 72nd, 73rd, 74th, 5th, 6th, 7th, 8th, 9th. This is the 79th box. Or if you really want to do it, you can just count them up. So that's going to be 78.7. And that's it.